is primarily because of the importance of it when it comes down to optimizing your scans for time, and of course optimizing your scans to avoid intrusion detection systems and firewalls as well. So those are primarily the two main reasons why we're going to be covering this module. And again, if we just break them down really quickly, firstly, we have already taken a look at some very interesting and important scans that give us a ton of information from our target. We're able to enumerate things like the operating system, service version detection, and we're also able to use Nmap scripts, so on and so forth. And this gives us quite a bit of information, right? However, this comes at a cost. The cost is that these scans will usually take quite a while, a few minutes, it can take from a few seconds to a few minutes based on the amount of information you're trying to extract from your target. And of course, it's a great skill is knowing how to reduce the amount of time these scans take, which is again where we're going to start off with using the help of timing templates. And then when we talk about reducing the overall time a scan takes, we now need to take a look at the opposite end of the spectrum, where we need to slow down the scan in order to prevent detection by intrusion detection systems, and to not alert any particular network monitoring devices that have been set in place that are actually monitoring the traffic. And again, a good example of that are intrusion detection systems. So again, on one end of the spectrum, we're trying to reduce the amount of time a scan takes, and on the other end of the spectrum, we're trying to be very stealthy with our scans and prevent any detection by these intrusion detection systems. So again, in this video, as I said, we're going to be taking a look at timing templates. Now, timing templates are used to specify the various timing options that are available on, so sort of increasing the performance of the scan to reduce the amount of time the scan takes. And because I said they have templates, the templates are denoted by the T option, and the templates range from template 0 all the way to template 5, right? So T0 to T5, and they all have nicknames or names that you can actually use to remember them much more easily. So T0 is what you would call a paranoid scan. So again, that is a paranoid scan. And a paranoid scan, again, is extremely slow. It's the slowest timing template available. And usually with T0 and T1, so T1 is also known as the sneaky template. So T0 and T1 are usually used to avoid intrusion detection systems. So if you want to slow down your scan or to reduce the performance, you might want to take a look at T0 to T1. I would recommend T1. You then have T2, right? So T2 is very interesting. T2 is known as the polite scan. And again, the polite scan is really not used that much. And then of course we have T3. So T3 is the default Nmap timing template that it uses. So when you perform a simple scan like nmap.scanme.org, Nmap will use T3, right? You can specify it as well if you want, but Nmap uses it by default. So T3 has a name of normal. Again, it makes sense. It's just a normal timing template. And then you get to the more interesting ones, which are going to be T4, right? So you have T4 and you also have T5. So T4 is known as the aggressive scan. And this is a very useful timing template, mainly because it's extremely aggressive. And again, you want to take that into consideration when performing your scans. You don't want to perform extremely loud and noisy scans and risk alerting an intrusion detection system or a firewall. However, if that's not in place, then again, you can use this to get your scans much quicker. And then you have T5, which is the fastest, and that is known as the insane timing template. And by the way, a PDF of this actual a table actually displaying the various timing templates, their names, and a bit about how they operate will be linked as a resource to this video. So again, in this video, we're going to be taking a look at parallelism in Nmap. Now, given that we've started taking a look at performance or scan performance and optimization, and we've taken a look at the various timing templates, which again will depend on various templates you specify or you choose to use. Those templates will determine how fast or slow a scan is. Now, when it comes down to parallelism, what we're talking about is essentially the amount of parallel operations you have running at the same time. Because again, to reduce the amount of time it takes to complete a scan, Nmap, based on your system resources, your network environment, and other factors that again it gets from its own heuristic analysis, it is able to determine how many concurrent operations and probes are being sent. And this is what we mean by parallelism. So as a means of scan performance and timing, and more to do with scan performance, parallelism can help you increase or reduce the amount, the scan time, or to again increase or reduce the amount of probes that you're currently being set. So again, using parallelism is very simple. You can set your minimum parallelism or your maximum parallelism. So how many parallel scanning options or scanning processes you have running at a given time. So for example, as I said, by default, Nmap will automatically do this, and I would recommend leaving this as it is. So again, using it is very simple. If I say nmap here, and we'll be using the scanme, nmap.scanme.org domain. So we say we want to perform a stealth. In this video, we're going to be talking about unresponsive hosts and changing the default timeout with Nmap. Now, this might be one of the most important videos in this module, and for a good reason. Now, when you're dealing with extremely large networks, and when I talk about large networks, I'm talking about, dealing with Class B networks, Class C networks, and, just increasing the range of IPs and the number of hosts you're going to be scanning, you're usually going to encounter a common problem. And that problem is how Nmap will deal with hosts or devices on a network that are not responding, right? Which, if you think about it carefully, can really affect your scan time. It can increase your scan time by an enormous amount of time. And the reason for that is quite simple. If I send a request to a target, right, or a host, and it refuses to respond, how does Nmap decide when it has waited long enough before it comes to a conclusion and says, hey, that device might be offline for whatever reason? Now, these reasons, again, it could be happening for various reasons. One of them could be there's an issue with that particular device, a firewall is blocking that device. There could be an issue with the network hardware, so on and so forth. So in the event that a device does not respond, you want Nmap to automatically say, all right, that device is not responding. I'm going to treat it as if it is offline. And again, this is very useful when you talk about discovery. So let's take a simple example or a scenario, right? Let's say I've been assigned to scan my entire network, and this is a Class C network, so we're going through two of my subnets. If you're not familiar with subnets, I attached a resource in the networking fundamentals section where I cover this, so you can actually check that out. So let's say I'm scanning a Class C network, and I currently have two subnets within my home office. And in this video, we're going to be talking about scan delays. Now, you might be thinking, well, why on earth would we want to delay our scans? Well, as I said, this is a technique of evading firewalls, evading intrusion detection systems, and evading administrators or network administrators. So let's just take a look at a simple example. Let's say you're performing a scan on a large network, and this network is being actively monitored by a network administrator who is monitoring the amount of packets being sent and is very keen and understands that what is the normal flow of packets and what is not normal. And again, even if you're performing MAC spoofing or IP address spoofing when performing your scans, a network administrator or an intrusion detection system will pick up on it if the scans are extremely noisy and you're sending tons of packets, which is usually the case with Nmap. Now, in terms of masking your scans, we've taken a look at various options. Now, in this case, we're going to be talking about scan delays. Now, that might seem like a very weird technique to use, but scan delays are very important because what this stands for is essentially the amount of time that we'll specify, or the threshold of time that, again, we will specify, under which Nmap is going to wait before it sends a second probe or a second or third and fourth packet, so on and so forth. Again, so it's just the period between one probe being sent and the second probe being sent, which can be very useful because an administrator, if he sees like tons of probes being sent, that is a huge red flag. However, if you have one SYN packet being sent and then after 10 seconds you have another one, that again is a very good way of evading detection, especially for intrusion detection systems. And of course, you can increase the scan delay duration to give you a more stealthier scan. So let's take a simple example as we've been doing so far. So what I'm going to do is I'm just going to say we're performing a SYN scan or a stealth scan, which is already stealthy, and an aggressive scan at that. And we're going to say, yeah, we want to keep this for the, we're just going to say port 1 to port 100. You know, let's just keep it nice and small. And we're going to run this on nmap.scanme.org, right? And what I'm going to do is we'll set the timing template to T4. And we'll open up Wireshark, and let me just show you how loud this type of scan is. So I'm just going to open up Wireshark, and I'm going to hit enter. So if a network administrator is looking at the network and is looking at all of these TCP SYN requests being sent, and by the way, you can actually take a look at them. The entire page is being filled with them, and it's from one device going to another. This is highly irregular internet behavior or connectivity in terms of packets being sent back and forth. And the other interesting thing is the network administrator doesn't see any responses, which again tells him that this is a one-way affair. And the only responses that are coming out are from various ports. So a smart network administrator is able to tell, all right, I know what's going on here, and is immediately able to actually flag this down as irregular traffic. And so for the intrusion detection system. So I'm just going to stop that capture. And we're going to take a look at what we want to discuss in this video, which is the using the scan delay option. So to set up a scan delay, we of course going to get rid of the timing template. We're going to use the normal timing template. We can actually even slow that down, you know, into using the T1 timing template. Which is the sneaky timing template, but we can change that to T1, and we can then say scan delay, and then we specify the duration under which we want to delay a packet being sent, so or a probe being sent. So in this case, we can say, let's say 10 seconds, right? And again, we can increase this to even up to a minute or 60 seconds or 90 seconds. In this case, let's just say 10 seconds, and I'll start a new capture here with Wireshark, and we'll open this up, and let's take a look at the delay here. So the scan is being performed now. And we still have our ARPs here. We're still waiting for the first request to be sent. And I'm still waiting for this. So there we are. We have our first ping, right? So you can see Nmap is now taking its sweet time. Every 10 seconds, we get a new packet being sent. There we are. We get our first TCP SYN being sent. Another 10 seconds, we'll see the second one being sent. And there we are, we get this is just an SSDP request, and there we are, we get our second request being sent again. And again, we're going to wait for 10 seconds. We just get another multicast from our network, and then we get our third one being sent. So after every 10 seconds, and by the way, you want to ignore the other traffic. This is coming from other computers on the network, but you can see that this can easily fool a network administrator or an intrusion detection system. Because of the time between each particular probe. Now, of course, this scan is going to take time, but if you're in a highly secured environment, this is a great way of evading detection, and both by network administrators and intrusion detection systems. So that's going to be it for this video, and I'll be seeing you in the next video.